Oh my God, I love that video so much. Hey guys, I just thought I'd share that with you. That was an old Nike basketball commercial that came out when I was in high school, and I remember just being completely obsessed with it. Such a good commercial. It's so awesome. It's got some ballers in there. It's got Darius Miles, Baron Davis, White Chocolate himself, Jason Williams. Go check out White Chocolate if you don't know what I'm talking about. He's got some interesting highlights from his NBA career. But I love that video so much. I remember when I was in high school, um, scouring the internet to try to find it. So, anyways, I digress. Great video though. Go check it out one more time. Some cool tricks in there. Anyways, we're here to talk about some tricks of our own. We're here to talk about properties of logarithms. Okay, and so I'm going to scroll down here, section 12.2, properties of logarithms. Now, a lot of the stuff in here is already stuff we've touched base on. Okay, a little bit yesterday. So hopefully not all this will be brand spanking new. That would be nice. Okay. Part one here is some warm-up problems. Hopefully these should go pretty quick, right? Rewriting from logarithmic expressions into exponential form. And so hopefully you guys remember my counterclockwise arrow trick to do those, right? You start at the base, the little number down there, right? And so this is going to become 5 squared equals 25, and you all know that 5 squared is 25, so that makes sense. Same thing with this next one. Log of y base a equals x. Make your little counterclockwise arrows there. A to the x is going to equal y. Okay? So counterclockwise arrows, those are the key. Alright, I'll leave it up for a little bit. The second part here, rewrite the following exponential expressions in logarithmic form. Now remember, with logarithms, right, you are trying to solve for the exponent, right? You are answering the question, what is the exponent? So whatever this is the log of, it's going to equal the exponent, okay? Now, the base of the log is the same as the base of the exponent, so little a down there with the log, and now the only part left is the y, so this is going to be the log of y base a equals x. And now if I make my counterclockwise arrows, right, I would get the original problem, a to the x equals y. So this checks out. Okay, let's do the same thing for 4. The log of something is going to equal the exponent 2. Base of the log is the same as the base of the exponent, and whatever I'm taking the log of is the number that's left over, right? Log of 49 base 7 equals 2, and again, this makes sense because 7 squared equals 49. Okay? Now let's do a little bit of evaluation. Okay, number 5, log 36 base 6. So remember, right, this is going to equal some number, which I like to represent with a box here, right? And again, remember, this is asking 6 to the what number, what goes inside the box, so that I get 36, right? And that would be 2, right? 6 squared is what gets you 36, okay? Now, this next one is a little bit more difficult, okay? The log of 27, log of 3 base 27, okay? And I'm actually going to show you guys how to do this on your calculator in a little bit, but this one's actually 1/3. 27 to the 1/3 equals 3. And if you remember, right, anything to the 1/3 power, let me start that over, whoops. Anything to the 1/3 power is the same as taking the cube root of it. And the cube root of 27 is 3. Okay? Alright. So again, 6 here is a little tough, and I'm going to show you how to do this on your calculator in a little bit. Okay? So don't fret too much over number 6. Okay? Alright, let's keep going. Next part here is the common log. Okay? And so remember, common log is just the log with the base of 10. Okay? And so, we don't always like to write the base every time. And whenever there is no base, like on example 1 here, okay, you assume it's base 10. All right? And so now you're answering the question 10 to the what power gets you 100. And you guys know that, right? That's going to be 2. Okay? And the nice thing is that your calculators always do base 10. Okay, so if you have your calculator with you, right, just type log of 100 into your calculator. Now, if you don't know where the log key is, let me pull it up here for you. Give me a second. Whoa, jumbo calculator. Not ready for that. Let's try this. There we go. Here's our TI-83, right? The log button is down here to the left, right next to the 7, okay, right beneath the squared key. Right, so I'm going to turn mine on. Okay, I'm literally going to type in the log. A parentheses is going to pop up, 100, close parentheses, hit enter. Right, and the log of 100 gets you 2, right, and that's because 10 squared equals 100. Okay. Hopefully our notes come back. That would be much appreciated, computer. Or feel free to freeze. Alright, so I'm having a wonderful day. Okay. Now, I still have the notes in front of me here. The U-try problem asks you to do the log of 3.82192. So that's exactly what I'm going to type in. Log of 3.82192. Okay, just like we did log of 100. Hit enter, right? And now let me jumbo size this, right? So this means that 10 to the 0.582 power gets you 3.82192. Okay, so that's the answer for the U-try right there. And I am going to try getting our notes back. Okay, let's take a quick break. Okay, so slight hiccup there. But we just went ahead and evaluated this next one, right? We hit log 3.82192 into our calculator, and we got 0.582, okay? So whenever it's just log of a number, right, you're just going to type that into your calculator, okay? And so here's another example. Log of 1,000. I'll give you a second. Think about it. Just log of 1,000. Okay? So again, common log means base 10. Therefore, the answer here is 3. Because 10 cubed equals 1,000. Okay? So there's your answer, 3. Alright? Okay. Let's go ahead and take a look at the next page. Okay? And we get 2 more properties of a log. Okay? Whenever you're taking the log of something where the base is the same, right? That's always going to equal 1, right? And now think about it. Take this log and convert it into exponential form, right? A to the first power should give you A, right? A to the first power equals A, right? Anything to the first power is itself, so this makes sense. Okay? Log of 1 base A is 0. Again, same deal. Convert this into exponential form. A to the 0 equals 1, which we know is true, right? Anything to the 0 power is going to equal 1. So, whenever you have the log of 1, that's going to equal 0. Okay? Alright, so let's go ahead and apply those here. We got some logs that are going to be a little trickier than they are. I think they're smarter than they are, but they're not. Okay? So, for example, log of 10. Just log of 10. Example 2 right here. What's the base? Well, we just talked about that, right? When there's no base given, that is the common log, which is base 10, right? So you have the log of something to the same base. The answer is 1. And that's because 10 to the first power equals itself. Okay? Now, this next one in the U try is also a little bit tricky, okay? This is log of 3 to the 4th power base 3, okay? Now, the answer here is not 1, okay? The answer here is just going to be whatever the exponent is, right? And the exponent inside the problem is that little 4 right there, right? Because if you convert this to exponential form, right, 3 to the 4th power should equal, well, what are we taking the log of? Well, 3 to the 4th power, right? That makes sense. Okay, so the answer for that one is just 4. Okay. Let's look at another one. Log of 1. Okay, it's 0. Don't let it fool you, right? Remember, this is common log base 10. Not that the base matters here, right? But it's the log of 1, that's 0, because 10 to the 0 power gives you 1. You try. Log of 1 base 7, again, is 0. 7 to the 0 power is 1. It doesn't matter what the base is. The log of 1 is always going to be 0. Okay? Alright, let's keep moving. So, top of the next page. Now, this is a very, very important formula right here. The change of base formula. Okay? Now, the things we've done in the calculator so far have been base 10, right? Like earlier we did, log of 100, and, the calculator does base 10 automatically, so it was able to spit out 2 for us, okay? However, you're not always going to have nice numbers like that, okay? So here's what you can do, and let me give you an example. What if I was doing the log of 100 base 9, okay? Now, if you think there's a whole number answer to that, there isn't, right? Because 9 to what power gets you 100, that's not going to be a pretty number, okay? Because 9 to the first is 9, 9 squared is 81, 9 cubed is 729. So 100 is somewhere in the middle there, okay? Now, here's what the change of base formula says. What you can do is you can take log 100 base 9, and you can split that up into 2 separate logs with whatever base that you want. Okay? So that's exactly what I have right here. I took log 100 base 9, right? And that's the same thing as log of 100. Now, what log of 100 in the numerator, right? Common log, because there is no base written, this is actually base 10. Divided by the log of 9, again, is the same base 10. Now, the reason why I'm picking base 10 is because this is the base your calculator can do. So if I want to evaluate log 100 base 9, I'm going to convert it to base 10 here. And now on my calculator, whoa, jumbo size again. What? There we go. Okay, the log of 100 base 9 is going to be the same as the log of 100 parentheses divided by the log of 9 parentheses. And now let me hit enter on that. Right? The log of 100 divided by the log of 9 is 2.096, if I round it there, right? So this is equal to 2.096. Okay? And here's the general form here for a change of base. Log of x base a is the same as the log of x divided by the log of a, where both of the bases here can be whatever you want, but in general, it's best to use the common log, okay? Alright, let's try another example. Example 4, evaluate log of 17 base 6. Okay, that's going to be pretty ugly, right? So what I'm going to do is I'm going to rewrite that, both of them with common log. So it's the log of 17 divided by the log 6. Go ahead and do that in your calculator. So log of 17 divided by the log of 6. And I got 1.581. Okay. 1.581. 581. Okay. Same thing with the next one. And I want you guys to try this, those of you who have your calculator with you. Log of 117 base 3. Okay? So, in your calculator, right, think about what you would type in. Okay? You're going to write in there the log of 117, close parentheses, and I don't know if I've mentioned that earlier, right? Make sure you're closing your parentheses on all these numbers, right? This is the log of 117 divided by the log of 3, okay? Now I'm not going to do this on the calculator for the interest of time, right? But you should get 4.335, okay? And again, what is this saying, right? This is saying that 3 to the 4.335 gets you 117. Okay, now we're rounding, so it's not going to be an exact answer, but for our purposes, it's good enough. Okay. Alright, so that's change of base formula. So we're definitely using that, okay? And here's one area where we are going to use it. Solving logarithmic equations, okay? So example 5 here says x equals the log of 23 base 5. Okay, so log of 23 base 5. Now, the 23 is not a power of 5, so I can't do that one in my head. So what I'm going to do is I'm going to apply change of base formula. Okay? And so x is also going to equal the log of 23 divided by the log of 5. Right? Type that into your calculator with the correct parentheses. And you should get 1.948. Okay? So again, what does this mean, right? This means that 5 to the 1.948 should be 23. Okay? Because remember, with logs, we're solving for the exponent. Okay? We're solving for the exponent here, right? That's what this log is equal to, right? This x value here is that exponent. Okay? So that's your answer, 1.948. Okay, on the U try, log of 81 base 2, that's going to give me my x value, so same deal. Change of base formula. So this is the log of 81 divided by the log of 2. And so, do that on your calculator. Again, use your correct parentheses. This should be 6.34. Okay. Alright. Last two here. And these two are a little bit different. Okay. Whoops, let me leave the answer up for the last one. There we go. Now, look at where your variable is placed, okay? Your variable is not where the log is equal to, right? Because there's a 3 there, right? This is the log of x base 5 equals 3. And now one thing you can do with these log problems is you can rewrite them into exponential form, right? This is the same thing as 5 cubed equals x. And now 5 to the third, we know what that is, right? That's 125, so that's my x value. Okay. Let's do the same thing for this next one. Log of x base 2 equals 4. Okay? Now, again, notice where the x is, right? It's inside the log. So one thing I'm going to do is I'm going to rewrite this as an exponent. So this is 2 to the 4th power equals x, right? And now 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16, right? The log of 16 base 2 equals 4, right? So my answer here is 16. Okay? So you're going to see a little bit of these on your homework, right? And now depending on where your variable is, right? So on these first two, okay, the value you were looking for, x, was what the log was equal to. So we used change of base up here, okay? And now down here, the variable was a part of the log. So to solve for that, I rewrote it as an exponent. Okay. All right. So that's all for me today. All right. I will see you guys tomorrow.